Hello and welcome to my channel. In this video we are going to solve a 3-mark question from Introduction to Trigonometry chapter which had appeared in CBSE board exam 2025. Now this question has an OR question as well. That is, either you can attempt the A question or the B one. So let us start with the first question now. Prove that 1 plus 1 over tan square theta times 1 plus 1 over cot square theta is equal to 1 over sin square theta minus sin to the power of 4 theta. So here let us start with the left hand side. Now remember that cot theta is equal to 1 over tan theta and tan theta is equal to 1 over cot theta. So cot and tan are reciprocal functions of each other. Now here we can see that we have got 1 over tan square theta. So we can replace this 1 over tan square theta by cot square theta. That is its reciprocal function. So this first bracket becomes 1 plus cot square theta times, now for the second bracket we have written 1 plus 1 over cot theta is tan theta. So 1 over cot square theta becomes tan square theta. Now once we have got this, these represent trigonometric identities which are 1 plus cot square theta is equal to cosec square theta and 1 plus tan square theta is equal to sec square theta. Now here 1 plus cot square theta is being replaced as cosec square theta and 1 plus tan square theta as sec square theta. Now remember that similar to cot and tan, which are the reciprocal functions, cosec and sine are the reciprocal functions of each other and sec and cosine are the reciprocal functions of each other. So in place of cosec square theta, we have written 1 over sine square theta times sec square theta becomes 1 over cos square theta. Now if we look at the right hand side, we need the answer in terms of sine theta. So we have to get rid of this cos theta. So for this we are going to make use of this identity, that is sine square theta plus cos square theta equal to 1. So we can rearrange this equation and get it as, now taking the sine square theta on the other side of equal to sine, we get cos square theta is equal to 1 minus sine square theta. So here in place of cos square theta, we have replaced 1 minus sine square theta. Now in the next step, we are going to expand the brackets in the denominators. So 1 times 1 in the numerator gives us 1 over sine square theta times 1 gives us sine square theta minus sine square theta times sine square theta gives us sine to the power of 4 theta. And this is our right hand side. So we have proved that the left hand side is equal to the right hand side. So this is our answer. Now let us move on to the OR question. Prove that square root of cosec theta minus 1 over cosec theta plus 1 plus square root of cosec theta plus 1 over cosec theta minus 1 is equal to 2 sec theta. So let us start with the left hand side. Now here for the left hand side, we have used the cross multiplication method and we have also used the laws of surds or laws of radicals. So if we are given square root of a over b, then we can write it as square root of a over square root of b. So we can split it apart. So applying this rule over here, we have multiplied this numerator, that is square root of cosec theta minus 1, with this denominator, that is square root of cosec theta minus 1. Plus, now again applying the cross multiplication, we have multiplied square root of cosec theta plus 1 with square root of cosec theta plus 1 over, now we have multiplied the denominators, that is square root of cosec theta plus 1 times square root of cosec theta minus 1. Now once we have got this, remember that if something is of the form square root of a times square root of a, so this will be equal to a. So applying this rule over here, we are going to get in the numerator. So here these both are same terms, that is cosec theta minus 1 and cosec theta minus 1, similar to this one. So we can see that the square root disappears and we get the same term. So here the square root has disappeared and we have got the same term, that is cosec theta minus 1 plus, now the same thing happens over here, square root of cosec theta plus 1 times square root of cosec theta plus 1 gives us cosec theta plus 1. That is by using this law of radicals. Divided by, now under the same square root, we have written cosec theta plus 1 times cosec theta minus 1. Now let us simplify the denominator. because this is of the form a plus b times a minus b. So in the numerator, the negative 1 and positive 1 gets cancelled. So cosec theta plus cosec theta gives us 2 times cosec theta over, now in the denominator, we have square root of cosec theta plus 1 times cosec theta minus 1, which is of the algebraic identity form a minus b times a plus b. So this is equal to a square minus b square. So in this case, it is going to be cosec square theta minus 1 square. Now 1 square is equal to 1. So we have written 1 over here. Now cosec square theta minus 1 is a trigonometric identity, which is 1 plus cot square theta is equal to cosec square theta. So if we take 1 on the other side of equal to sign, we get cosec square theta minus 1, which will be equal to cot square theta. So here in the denominator, in place of cosec square theta minus 1, we have written cot square theta. Now in the next step, we have simplified it further. So the numerator stays the same, that is 2 times cosec theta over square root of a square term, the square root and the square disappears, giving us cot theta. Now cosec theta is a reciprocal function of sin theta. So in place of cosec theta, we have written 1 over sin theta. So the numerator now becomes 2 times 1 over sin theta over cot theta is written as cos theta over sin theta. Now sin theta and sin theta gets cancelled from the numerator and denominator. So we are left with 2 over cos theta, and the reciprocal of cos theta is sec theta. So here we get 2 times sec theta. That is 1 over cos theta is replaced as sec theta. And this is what we had to prove on the right hand side. That is, the left hand side is equal to 2 times sec theta, and we have proved it over here. So this is our right hand side. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.